welcome to track 2 of Joy. And I want to present to you Federico and Manish, who will explain us a little bit more about modernization of applications on AWS.
Thank you so much, Yannick. So hi, everyone. I'm Manish. I'm Senior Solutions Architect at AWS. I'm glad to be here. And today we are going to talk about application modernization on AWS. So the topics that we're going to touch upon today is that we'll start by discussing that why the organizations are doing it in first place. Why is it needed? And then we'll go on to discuss that what are the various approaches that we can take to modernize the applications on AWS, and how does the evolution looks like. And then we'll conclude with an example using Strangler pattern to modernize the application. Okay. All right, so why are the organizations trying to modernize? What is the driving factor? Is it just because everyone is doing it, so it's cool? Not really. So the studies from various research groups shows that CIOs state, most of the CIOs state that more than 75% of their time is being spent on maintenance and the operations of the applications, while they should be spending that time on bettering the experience of the customer to drive the business goals or to build the business differentiators. And they want to reverse that trend. It's not happening at this time. Next slide, please. So modern application development is a powerful approach to design, build, and maintain the applications and softwares in cloud. It provides value in 3 forms. First is the speed and agility. So your builders or developers, they don't have to spend time on maintaining infrastructure, that they can focus on what's important for the business to build new functionalities and features. It helps them to move faster. Second is the security and the resiliency. So in the traditional approach, quite often we build the core business application, and then as the afterthought, we add the resiliency as well as security into that. But with the modern approach, these things are built in the native components, the application components which you are using to build the application. And the cost, of course. It's good to have these goodies, but how will that help with the cost part? So it helps you to optimize the cost. The cost follows the usage pattern very closely. And at the same time, it provides you the insight into your spendings more closely related to your business functions. So the visibility is more in this approach. Okay, so when we think about modernizing the application, I'm sorry if I'm coming in between. So when we think about modernizing the app, we have to think in 3 paradigms or 3 pillars we have. First is the agile development processes. It gives the agility to the developers and builders to reduce the complexity to configure and provision the resources. At the same time, it also gives the ability for them to move faster and to make sure that things like the resiliency or the best practices for the security, resiliency, performance are all built in. Second pillar is the adoption of modular the architecture patterns. What does that mean? The idea here is to adopt or the architectural concept of complete ownership. Like with the microservices, so here the whole service is owned by a single team, including its data, its SLAs, its complete deployment pipeline, and everything else. And you can implement it in the container serverless. It's a topic which we'll discuss. But the idea is to adopt these modern modular architecture patterns. Then the next is the serverless operational models. And here it's simple. We want to remove the heavy lifting. And when I say that, it means the patching, provisioning, hardening, or creating Solaris zones, or maybe I'm too old. So all that stuff, you want to get rid of that, right? The focus should be to abstract the infrastructure from the applications so that the developers can focus on driving the business goals and building the business functionalities. So how the pathways to modernize look like? We often talk about 5 hours, 6 hours, 7 hours to modernize. So how exactly like that happens? So when we talk about modernizing, we usually have 3 collaterals: the application itself, the database, and then things running on the legacy operating systems because you have compatibility issues, or you had punitive licensing models, or you had the vendor lock-in. So that's the third bucket, right? Now it's possible that you can take application and modernize it all at once and run it in form of microservices and run it on the serverless. But we all know it's easier said than done. So the path that most of the customers take is to start with the first R, which is rehosting. Just to move the application to the cloud, like AWS on EC2, for example, on a compute platform. So you already get rid of managing the hardware infrastructure. You are more agile, more scalable. From there, you keep on gradually modernizing the application to refactor it or whatever you want to do. So that's the first step that most of the customers take. Now from there comes into picture the first R, or to modernize. To refactor. Now refactoring it to move the application to more the cloud native way of running. You can break it into microservices, run it on containers, serverless functions. At the same time, you also build your CI/CD pipeline to manage the underlying platform and deployment. So that's the first way. The next is replatforming. You don't always have to do everything by yourself. We have higher level services available for everything, MLAI, the data analytics, or the IoT or DevOps or whatever you want, right? And by doing that, you remove the heavy lifting and you just delegate the requirement of doing anything with the platform to cloud. So that's the second. Then you can do same thing with the database as well. You have the databases available for every possible kind of data. You are working on something related to crypto. We have the database for the blockchain. For time series data, the graph data, you have the JSON documents, or the key value pairs, or even the classical RDBMS. So you have the database for every kind of requirement. The next R is replacement. So as I mentioned briefly in the beginning, that you might have some components which are running on the legacy operating system because you were logged in, and the component there is not compatible with something else, or there were some the punitive licensing terms which you could not break out of. So most of the customers tend to break out of that model and move towards the open source framework. That helps your developers to be more innovative, to follow the latest market trends, to keep up with the technology changes which is happening in the market. So these are the typical ways, or at very high level, means we can have more pathways to modernize, but these are the typical ones that we see with our customers. Okay, so let's talk about one of the interesting architecture pattern which is used, and I'm sure that all of you are aware of this microservices. So what is it? It has its own domain logic, its own deployment pipeline, and in a sense it's more decentralized, that it has its own testing pipeline, its own SLAs, it can be scaled completely independently, and if you make changes to one service, it won't be impacting the other. The idea behind the microservices that when it is deployed in isolation, it provides a business capability. And why is it fit for the modern architecture? Because it's modular, of course. So you remove the interdependency on the teams. One team can move at its own pace. They don't have to wait for the other teams to complete their features or releases to move forward. But at the time, if you deploy it on the modern infrastructure, they are more efficient when running. Okay, so the architecture is fine. How to deploy it? Serverless. And why? 4 reasons. So first is the agility. So again, your team does not have to manage infrastructure. There is less regret cost. And when I say regret cost, it means if a POC or experimentation fails, you're not sitting with hundreds of man hours you spent on managing infrastructure, or you are not stuck with the hardware that you have no use for. Next is the performance. You can scale it virtually to any scale and very quickly, very dynamic in nature. Scaling up, scaling down is quite easy and automatic in most of the cases. The cost. So as I said, that it follows the usage patterns very closely. So if you have a low season, you will not have hardware just sitting there. If you have a high season, it can scale as fast as you want. Security. So again, like these services are secure. It's like natively built in, so you don't have to strap it on. So you just delegate these tasks to the provider of the service. So these are the primary reasons, and like another good thing with the serverless services is that it follows the design principle of web. Small pieces loosely joined together. And then these pieces communicate using integration services like messaging solutions or API gateways or orchestration services like step functions. And it's quite easy to build a new functionality, a new feature, or new app using these loosely coupled small pieces. In most of the cases, you'll have the APIs as the entry door in the application where the users will reach out to. And after that, these pieces will continue to communicate with each other using messages or events, right? And we'll see example of that in the later part of the presentation. Okay. So let's see how the evolution for a typical organization looks like. So how exactly they move from one stage to another. In most of the cases, they start from the physical machines. They have their own problems, starting with you have to do a lot of capacity planning. That's mostly a guesswork, no matter how many tools you have. And then after that, you have to maintain the hardware infrastructure. The deployment time is months, sometimes blocks innovation because of high regret cost. So what's the next best thing? VMs, of course, just move to EC2. You already have solved many problems. You don't have to manage the hardware. You have more agility. Now you can spin up VMs in minutes, right? So it's already very fast. But still you are stuck with operating system. You have to do heavy lifting to manage OS. And that's not adding any value to your business, right? So what else can we do? Containerize? Yes, of course. Platform independent, more agile. Now we are talking seconds instead of minutes. So they're much more faster. But still, you might be running your containers on operating system. So still, the heavy lifting is there. The end game is to move it to the serverless. You completely do away with any kind of infrastructure maintenance here. You have things like Lambda or Fargate. And that's only for the compute, but same applies for any other things as well. So here you completely delegate all the heavy lifting to cloud. You have the builders can simply focus on writing the business logic and the code. Okay. So we see two types of patterns how the adoption happens. In first one, we see that customer start with the rehosting first. They move to cloud first, the EC2. Then they modernize and move to containers. And then slowly they move to the serverless, right? So they are trying to optimize the cost first. But the end goal is to reach the serverless state. While in the other model, the customer focus on modernizing the process first. It means that they decompose apps, they run it on containers on-prem. They don't move to cloud yet, but when they have containerized the apps or have decomposed it into microservices, let's say, then finally they move to Lambda functions or serverless functions. So the end state is still same. But some of the customer, they do it directly, just decompose and move. Yeah, why not? It's possible. Depends on the risk appetite you have, the kind of business, the conditions you have, or imperatives you have. But it's not unknown. That can also happen. So how do we trace the path starting from a monolith to the serverless state? We talked about it, but how exactly it will look like? Let's see an example. Let's say you have done some work and decomposed a monolith into microservices to some extent, while you still have many apps which is running in the same state. But still, you have done some work. So let's move them to containers on cloud in the first path. Now, you might still think that, let's say, domain-driven design principles I followed were not correct. I want to further improve it. Or my bounded context was not very good, so I have to refactor my microservices still. But that's fine. First, you have containerized the app. You are more agile now. And we'll see that what to do with the rest of the stuff. Now, what about the good old monoliths? That's, you simply rehost, like to start with. You rehost it, and if some part of it can be moved to containers, just do it. If not, just rehost the complete app on EC2. You are more scalable now. From there, let's get back to our first migration path. You have containerized the app. From there, you start to build new features in the serverless way, and you continue to decompose the app as well. And that is where Strangler pattern comes into play. But I'll not go too deep into it. Federico will cover that in a bit detail. Coming to the second part. So how do we move forward from here? So we build a facade. What a facade is, it's the abstraction of complexity which you are going to bring in when you are trying to modernize, right? A facade can be built using the API gateway, load balancers, or any custom service. But the idea is that any complexity, your users will have seamless experience, and you can continue to decompose the monolith functionality by functionality in the hindsight. just like we renovate the houses in Belgium. We leave the facade on and complete the building is renovated. But here, you continue to decompose the monolith, and at the end state, you might see that some of the functionalities are still running on servers, or you can very well see that everything has been moved to microservices running in serverless functions. But even if you have some components running on servers and you think that it does not make any sense or add any value to move it to functions, well, that's fine. Your user will never know. It's completely seamless because of the facade, and most of the parts have been moved to microservices. So that's kind of the target state here. I think it's a good segue that I handed over to Federico, which will dive a bit deeper into these examples.
Thank you, Manish. So in the second part of the presentation, I will go through, let's say, practical example of how we can apply this approach to actually move the application from a monolith on-premise to a microservice-oriented, mostly serverless design and architecture on AWS. The idea is that in this example, I will apply the strangled pattern strategy, which was introduced by Martin Fowler. And the idea behind the strangled pattern is to let to initially move the application and start building some of the functionalities of the application next to the main monolith as a microservice, and start routing traffic to the microservice version of those functionalities iteratively, until we have either the whole application basically brought to its microservice functionality, or at least we removed some of the, let's say, performance blockers that you have on your initial monolith architecture. So to do that, we start with an example with a monolith application that would have both, let's say, application layer and database hosted on-prem. And the first step for the approach is to rehost the application on the AWS cloud. So as you can see, we're going to move, let's say, the web and application layer to EC2 virtual machines. Running maybe behind an elastic load balancer. You have an auto-scaling group that you can use basically to scale the infrastructure based on the load of your application. And the database layer in this case was moved to an RDS with replica in a multi-availability zone setup. So you already have a first move that is not only a rehost to the cloud with everything on virtual machine, but also using a managed service like RDS, which is our relational database service, where Amazon starts taking care of some of the heavy lifting of patching the system and building the database from scratch. So as a first step, we move the application to AWS, but we can still see it as kind of two replicas in two availability zones of the monolith that we had on-prem. So in this case, we didn't really break down the functionalities in different microservices. Moving forward, the next step is to build the facade that Manish was talking about. So the idea here is to add an API gateway in front of the ELB, which at the beginning would act basically as a proxy. So requests coming from your client would get to the API gateway. An API gateway is a serverless service that we offer, which allows you to basically create and manage APIs at scale. At the beginning, you can create a stage in your API gateway that would simply redirect all the incoming requests to the ELB, and then the request will be served by the application rehosted to EC2 and RDS. The benefit of having API gateway in front of your application is that it can give you, different ways to monitor the performance of your application while the request is going through API gateway. So for example, API gateway can integrate with CloudWatch, which is one of our managed services that allows you to, collect metrics on the way your application is performing at different level. And in the integration with API gateway, basically it can collect metrics around the API call performances. So for each API call, for example, you can see the rate of, if you enable caching, you can see the cache hit and cache miss rate, or you can see also the latency of the different API calls. The reason why this is important is that it can allow you to basically identify the functionalities that you have in the monolith that can cause some performance degradation to your application. So the idea is to identify through these monitoring capabilities that the cloud offers, what are the, let's say, hotspots of the application that at the moment is in a monolith state. Another alternative to do a similar exercise is to use AWS X-Ray, which is another serverless managed service that we offer to collect, let's say, traces of the requests going through your application at any point in time. So it provides a different type of, let's say, monitoring results in the form of traces that basically show you the whole path of the request from the client coming through the different, let's say, the different components of your application, and shows the performance at every step to identify what are the building blocks that can cause latency in the application. So this is, let's say, another alternative to say, let's identify what is this, let's say, hotspot that is causing, let's say, the performance issue in the model. When the functionality is identified through the metrics, the idea is to start building that functionality in a different format. So in this case, Lambda is being used. So the idea is to build a Lambda function. Lambda is our serverless event-driven compute service. You can build the functionality in the Lambda function, and then the Lambda service will take care of managing the whole underlying infrastructure for you. Every time you need to execute the functionality, you will have a call going through the API gateway. You will call your Lambda function instead of the monolith, and we will see how that happens in a later slide. But the idea is that then Lambda spins up the environment that you need to execute that functionality only when that functionality is called, and then removes all the resources immediately after the execution, and you're only billed for the execution time of the Lambda function. So this to tie back to the advantages of serverless that Manish was mentioning in the previous side of the slide. So with this approach, basically, you will only pay for the actual compute resources that you are using. At the same time, this part of logic might need to interact and read some data from your data layer, and it doesn't necessarily need to be the same database that you have in the monolith version of the application that you're rehosting. So before going to the way to release the new microservice that will be, let's say, coded in the Lambda function, I will just mention a couple of different ways that your new microservice that you added, what is called in the Strangler pattern, the Strangler, so the new microservice added next to the monolith, can access data based on the use and the functionality that you're coding in it. There are mainly two approaches. So the L-shaped pattern that you see here is used mainly when you have like a consistent, let's say, data structure mostly. So when the new functionality that you add to the next to the monolith needs to access more or less the same data. And the idea is that in this, it's used usually when the strangler only needs to read data from a new data source. In this case, let's say the main write operation happens on the old data source, which will be the RDS database that you have seen in the previous architecture. And there is a synchronization that happens to the new data source where the strangler reads from. The idea is that with the new data source, you can pick some of the different services the AWS offers to use the database offer, for example, that works best for that type of functionality in your application, or to optimize at least the performance of the application. Yes?
I have a question on the previous slide.
On the previous slide, yeah.
On this one, you explained that your Lambda function would be spinned up and your environment would become available. What block within the AWS is doing that part?
So it's the Lambda service as a whole. So Lambda as a service basically allows you to define separate functions. So each function is the logical building block of your application. The way that, and you can basically specify, for example, what is the programming language, what type of runtime do you need. You can bring libraries, for example, to your application. That said, this is all that you need to define, basically. So you don't need to say, I need, let's say, a virtual machine with a certain number of CPU and a certain amount of memory available to run that code. all of that is managed by the Lambda service, and this is basically why serverless then brings all the advantage. Every time a function is basically invoked in an event-driven fashion usually. So every time there is an event that triggers that function, the service will take care of spinning up all the resources that are needed to execute that piece of code, if you pass me the term.
And can you also fine tune, because I think if you have a heavy load, spinning it up is also having delay.
Yeah,
So
so...
you find to have your service available
Yeah.
overall.
Yeah, so there is some logic in the Lambda service of warm start and cold start. So basically when the function is not called very frequently, you might have some cold starts where the environment needs to be initialized. But if the function is called very frequently, then on a heavy load and a high peak traffic situation, the function also works in a hot start fashion. So basically the initialization of the environment is kept alive so that you can execute the function multiple times on the same type of execution environment. Yeah. Moving to the, let's say, so with the L-shaped pattern, basically we would perform the write and reads through the monolith on the old data source, synchronize the data with when you have eventual consistency that is, let's say, acceptable for the new functionality. You can use this approach to read from the new data source. The opposite, basically, pattern is the backward L-shape. So the idea is that in this case, you would move the write functionalities to the new microservice that you created. You can read and write from the new data source, and in this case, you need to synchronize the data back to the old data source when the functionality that is still part of the monolith needs to read the data for to fulfill basically that functionality. Between one and the other approach, basically. How to choose between one and the other approach then depends really on the nature of the application and the way you are building the microservices around the monolith. So the next step is really to release our new microservice and our new strangler. And the idea is that in the call that you have in the API gateway will not only add as a facade that will send all the calls back to the monolith, but starts, diverting some of the calls that are coming from the client to the new microservice. In API Gateway, there is the concept of stages, so you can define different stages for your API, and you can apply a canary type of release to different stages, which means that basically, gradually, a certain percentage of the requests that are coming to the API Gateway will go to either your monolith application for those functionalities that are still there, or to your new microservice when you start testing basically the logic that you put in the new Lambda function. Then, of course, with the canary deployment, basically you can start with a lower amount of traffic, see if the new functionality is performing as expected, and with that, basically, increasing the load as you see that the performance is actually improving. Now, this is an iterative process, so the strangle pattern works in iterations, and the idea is that as soon as the first hotspot in your application is now built into a microservice with Lambda and DynamoDB, you can start, continue to monitoring the performance through API Gateway and CloudWatch or X-Ray, and identify what is the next hotspot in the monolith. So the next application might be something that is not necessarily like a very short functionality, very, let's say, short application logic that you can execute in a Lambda function, but maybe it's something that you prefer to move to a container type of execution environment. So this slide basically shows how you can add an additional microservice next to it. In this case, it's still built in a serverless version, but using Fargate, which is basically our container offer, our serverless container compute service, basically, which allows you to deploy, containerized application, letting AWS take care of the orchestration of all the underlying infrastructure to deploy the containers. And in this case, this part of the application might need, a relational database to read the information from. And you can see the data, instead of being migrated to DynamoDB, like in this case, using our database migration service, was moved to Amazon Aurora, which also offers a serverless version of the product. So Aurora Serverless V2 was released not too long ago, and basically it provides you a relational database with commercial, like let's say enterprise scale type of performance, but with reduced cost and an underlying infrastructure that helps also with redundancy of data. So this is an idea just to show that there are different ways to build, serverless microservices according to the functionality that you are trying to build next to the monolith. So finally, if we continue to iterate, there is going to be a point in which the application is not going to be a monolith anymore, but you have different components that are decoupled one from each other. And then you end up basically iterating from the strangled partner, and you move from the monolith to this kind of microservice-oriented architecture. One thing that I wanted to point out is that the last microservice that you see here on the right-hand side of the slide is in this case not built on serverless technology. So it's still built on EC2 and RDS. This is just to outline that you don't necessarily need to build using serverless, but there are use cases in which serverless can really help you. It can really, provide additional benefits to building those, separate pieces of logic. But there are some functionalities that can also be built on, EC2 machines or RDS and can, work perfectly fine on those type of technology with the right level of performance. So you might, want to, let's say, wait for those functionalities in the initial monolith that are working correctly, keep them, running as needed, and then decide when it's the right time to move them to a different type of underlying architecture. And basically, with this, we complete the flow from the monolith to the microservice. Yeah.
Question again here, because most of the times with the monolith, people are happy because if they have to do security and have to do permission checks and stuff like that, they have to read now if you split it to 3 databases sometimes to execute their permission checks. And of course, if you change your business functionality to these small pieces, that's most of the time the easiest part, I would say. But where would you place in this place then if you need the 3 databases for security?
Yeah, so I think there are 2 ways to kind of address your question. Like one way is what Manish was mentioning earlier in the presentation. I think the concept behind microservice is really to give the team that is responsible for that microservice, let's say, full control end-to-end. So basically, if let's say I'm managing this part of the functionality, I would need to make sure that the team managing this part of the functionality is able to secure both the, let's say, the Lambda side of things, but also to secure the data in the DynamoDB table, in DynamoDB basically. So it depends on whether, the security team for certain part, let's say your data access and so on, is to be centralized, or if every team can operate independently. Basically. And then if you have a centralized data, let's say, data platform that different microservices can access, that is also possible. And you can have a team that is managing basically all the data of the different data sources that you have, managing security around that, and providing to the different team access to those data in a secure way. Now, it's a very broad topic, and it really depends on the use case, so it's difficult to give you like a specific example. But there are different ways to operate, and it really depends on how you organize then your way of working. So if you want really teams to have responsibility on everything that is related to the functionality that they are building top to bottom, then that team will be responsible for securing both the compute layer and the data layer of their microservice. Otherwise, you can also decide to centralize data access, and let the data team then provide access only to the right applications. And then the way to build it on AWS really depends on the different scenarios, the data source that you have, and how the rest of the ecosystem looks like. I think we are at the end of the presentation, but we probably have 5 more minutes, so if you have any other questions. Yep.
I see a big challenge in the transition that you're doing, and also in the end picture, a big challenge in the knowledge that is required for a team to still understand how everything works. You have so many different parts now in the end. From a monolith, you have so many different. Are there tools or are there ways to handle this aspect of knowledge, extra knowledge that is required for a team to still be efficient?
Yeah, so from an AWS perspective, we provide like different types of support basically to our customer. When it comes to knowledge of the different services and the different, let's say, building blocks that you have in this type of architecture. So we have like a training and certification team. We have our supporting team as solution architect. We do activities with customers and partners to make sure that we can enable our customers' team to operate in the cloud and manage the complexity around using the different services. When it comes to the how do you split the monolith in different functionalities that are kind of distributed in different teams, there is always a component of making sure that you document the different functionalities and you have a certain level of communication between the different teams. Many times, like the communication between the client and the microservices happen via API, but many times there is also an API-driven type of communication between the different microservices. So one thing that we have seen working with many customers is that making sure that your API communication layer between the different microservices is maintained with a certain level of quality and documented very well for the other teams to use can be a key to make sure that then the interaction between the different teams is seamless. Manish, I don't know if you want to add
Yeah, I
something.
just want to add one point, and along with that, the training and resources, we have many things like reference architectures, use cases available on the public site to get you started. So that's also something which you can refer to, that how to start to modernize the monolith.
Was another question, I think? Yep.
When you explain this seven steps, it appears for me that the first step, rehost the monolith on AWS, that seems to me the hardest one to do. And the most where people are scared of. Do you feel the same?
In which sense you would say is the hardest one?
People are afraid to do that first step, because it's not only database. You have also interfaces, maybe on-prem, and that you also have to arrange with other application. You also need roles on AWS or on-prem, etc. So it doesn't seem. I think the most time is spent in that, and not in the 6 steps.
I see.
But
Yeah.
I think it is.
Yeah, so quick disclaimer, for the sake of this presentation, that step was made simple, like on purpose, because the idea was to present like the way you build the microservices around it when you are on AWS. Definitely, the first migration is a significant step, and it's not something that happens from one day to another. And we have different mechanisms that we use to help customers to perform that first migration. So we have a dedicated migration team. We can work on migration readiness assessment. We have different ways to try to understand how your ecosystem on-prem looks like in terms of, and assess what would it look like on AWS. So the number of machines, the number of databases, the number of servers, and basically how we can lift and shift that type of application to the cloud, moving it to an EC2 based environment. But I agree with you, like it's a whole process that we need to go through. At the same time, there is also the possibility that you still need communication to an on-premise environment. So not necessarily then everything stays on AWS and only communicates to AWS. So we have different customers that start iteratively moving applications and workload to the cloud, and we have the capabilities to build those, let's say, hybrid architecture, where a component of your architecture, of your application and your business is still running on-prem, and you have something running to the cloud. So there are different, let's say, different ways to approach that. But for the migration step, definitely that's if we need to do that type of exercise, there are different paths to do so, and we have multiple programs that we use to support our customers for that. Manish, you want to?
No, I think you covered it well.
Yep.
One of the biggest blockers or concerns that I hear from companies is that to move to the cloud is that they need to keep their data private. They can't afford to have, say, Amazon in this case, have access to their data if they work for the government or if they have medical data or stuff like that.
Yep.
Is there solutions for that to guarantee that Amazon cannot access the data?
Yeah, so I think the best way and what kind of speaks for itself is also the type of customers that we work with, right? So through the years, we have customers that operate in very regulated and strict industries. We have banks working with us. We have government agency, health agencies working with us. And we even have like some organizations that run on AWS and you can see as competitors of other branches of the Amazon business. If you think that the Netflix infrastructure runs almost entirely on AWS, and we have Prime Video, that we hear those type of, let's say, concerns around data access, but we have use cases and different ways, and of course the technology behind to prove to our customers that they are in control of the data that they move to AWS. So there is a component of we address that with what we call the shared responsibility model of security in AWS. So AWS is responsible for the security of the cloud. So of course, when you move data to AWS, we are responsible for securing our data centers, the underlying infrastructure, all the storage compute layer that you would use, basically. And our customers at the same time are responsible for the security in the cloud. Security in the cloud, basically. Which means, in fact, like building your application in a secure way and implementing all the security features that we provide to make sure that nobody access your data. To put it like very simple, for example, like if you put data in a database in RDS, you need to make sure that from a networking perspective, that database is in a subnet that doesn't have direct access to the internet. So to make sure that the only access to the database, for example, can come from your application layer. And any connection attempt from any other IP address anywhere outside of that application layer is rejected. So we have different, this is just a very high level example, but for different use cases we have many different ways to secure data and application, and security has always been like a top priority for us.
But the keys used to encrypt that data, they are always available to Amazon.
So for encryption, we have for encryption keys and encryption of data, we have a managed service that is called KMS, and that service basically builds you can use like customer managed encryption keys, but you can also use encryption keys that are managed by AWS. The way the service works is that it uses an envelope encryption, and the main key that is used for encryption is stored in a secure HSM, basically vault, which we can physically not access. And the only keys that the keys that the customer has basically provide the encryption via API calls, interaction with the system. But then the service itself that is used to build the encryption is based on HSM technology. So it's based on technology to secure the keys and make sure that they are not accessible and they're secure for our customers. Anything you
No,
want to
I
add,
think
Manish?
you covered it well.
Any other question? Otherwise, I think we are a bit 4 minutes over time. So thank you very much for attending and for all the questions, and I hope it was useful for all of you.